So we are in our final unit before the STAR test, which means that we're learning about exponential functions, which is the final type of function we're going to learn about. In order for us to handle exponential functions, really not even necessarily that, but as part of exponential functions, we're going to learn exponent and radical rules. So that means how do we, there are some tricks behind multiplying and dividing exponents. In the past, what we did was we expanded them. So for this one, for example, we do a, so because there's a squared, then there's b to the 7th, so there's b, 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 b. We expand the top, we'd expand the bottom, and then we'd cancel. So I can cancel a 1 on the top and 1 on the bottom, 2, 3, and then whatever's left is my answer. So I have a to the first, and that 1 is invisible, I don't have to put it. And then I've got b to the 4th. And we don't normally show the 1. Okay. Likewise, when we did multiplying, we did a, b, b, b to expand this out. Then we expanded this one with a, b. And then we just counted up what we have. I have 1, 2, 3, 4 a's, so I have a to the 4th. And then I have b, 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 b to the 4th. And by the way, on this one, I actually ended up with a, b to the 4th over 1 because I have nothing on the bottom. And when there's nothing left on the bottom, I put a 1. So that means all of this stuff wound up on the top. Okay, so that's what we did before. Okay, now you can still do this. There's nothing wrong with doing this, but there are actually shortcuts and there are actual exponent rules. And these are on your formula chart. We have a whole section of the formula chart for properties of exponents, and it's got these rules on it. So what we're going to be doing today and tomorrow, so today on your video and tonight and tomorrow in class, we're going to actually make ourselves a foldable with all of these different rules. So we can skip those two for now. So when you're multiplying powers, so what we had done is we had before, so remember we have this invisible 1. If you remember, we have around every variable, there's an invisible exponent that's a 1, there's an invisible coefficient that's a 1, an invisible denominator that's the 1. We're going to kind of be looking more at this invisible exponent. Okay, so for this one, if you notice, I had 2 a's on the top and 1 a on the bottom. 2 minus 1 is 1. I had 7 b's on the top and 3 b's on the bottom. 7 minus 3 is 4. So when I'm dividing, I subtract things that have the same base. So let's take a real quick step back, and on the back, let's talk about this. So when we look at an exponent, there's different parts to it. There's a base and a power. Okay, so this is my base, and this is my power, or exponent. Okay, in order for me to be able to use any of these exponent rules, I have to have the same base. So notice over here, I couldn't say b to the 7th over a to the 1st. Those aren't the same thing. Again, it's a Chickamauga problem. It's a combining like terms thing. I can't do math on things that aren't the same. So the b's are the only thing that I can cancel with b's. So I can only use the exponent rules when they have the same base. Okay. So when I'm multiplying, so let's look at multiplying. When I multiplied here, I had a2 and a2, and over here I wound up with a4. b3 and b invisible 1, 3 plus 1 is 4. So when I'm multiplying exponents, I'm adding the exponents. So if the bases are the same, then we add the exponents. So let's zoom in on this. Let's take another look here. Okay, so for this first one, it says a to the 3. Remember, when they're in parentheses smashed up against it, that means we're multiplying. A to the 3 times a to the 5th is a to the 3 plus 5, because we're going to add those exponents. 3 plus 5 is 8. So a to the 3 times a to the 5 is a to the 8. Now, this is when we're going to do when we're going to group things up. So I have 3 n to the 7th r to the 3rd times 2 n to the 4th r x to the 2nd. So I'm going to kind of group them up. We would have put, remember when we did it, we would have put parentheses around them. Kind of like that to kind of group up the things that are the same. So I have 3 and 2. So the numbers go together. I have n to the 7 and n to the 4. So that's going to be n to the 7 plus 4. Okay. My r's, I have r to the 3rd plus r to the 1st. 3 plus 1. And it's really important to write that invisible exponent, because otherwise you're going to forget to do it and you're going to say r to the 3 plus nothing, which is r to the 3rd, which is not what you have. And then I have x squared, and it's the only one I've got. So now I'm going to combine those. 3 times 2 is 6. N to the 7 plus 4 is 11. R to the 3 plus 1 is 4. X squared. So again, all we did was add up those exponents. So if I have this, x to the a times x to the b times x to the c, it's x to the a plus b plus c. All right? So that's multiplying. When we multiply, anytime we're dealing with multiplying things that have the same base, and they have exponents, we're going to add up the exponents. Now, when we divide, if the bases are the same, we're going to subtract the exponents. Okay? So if we look at this first one here, a to the 5th over a to the 3rd. Well, 5 minus 3 is a squared. Okay? Here I have 3 to the 4th y to the 5th over 3y squared. Now notice, in this one, 3 is the base. So I have 3 to the 4th, so we're actually going to be subtracting these. It works with numbers too. So 3 to the 4 minus 1, y to the 5 minus 2, equals 3 to the 3rd y to the 3rd. And if you wanted to, you could put 3 to the 3rd in the calculator, which gives you 27 y to the 3rd. Okay, and this last one here is 7 to the x over 7 to the y. So I'm going to do 7 to the x minus y. All right, so that's our multiplying and dividing rules. And then there's one more that we need to talk about, and this one is actually like really easy. Okay, so if I use my dividing rule on this one, 15 to the 2 over 15 to the 2, well, that would be 15 to the 2 minus 2, which is 15 to the 0. Okay? 47 to the 4 minus 4 is 47 to the 0. 4 to the 3rd over 4 to the 3rd is 4 to the 3 minus 3, which is 4 to the 0. Okay? Now, if I put those in my calculator, what am I going to get? All right? Well, let me get my calculator, and then I will answer that question. Okay, I'm back now. So if I put 15 to the 0 into my calculator, whoops, 15 to, well, let me just clear all this out. 15, and remember, I'm going to use this button here. This is my exponent button, the one above the divide, the caret. So 15 to the 0 power, well, that's 1. Okay, and think about this. If I have 15 squared over 15 squared, any number over itself equals what? 1. Okay, so now I have 47 to the 0. I get 1. What do you think 4 to the 0 is going to be? Yep, probably 1, but let's check. 4 to the 0 is 1. 739, it's 1. Now let's try this one, negative 32 to the 0. Not 1, it's negative 1. Because remember, our calculator, we do the exponent first, 32 to the 0 is 1, and then we take the opposite of it. Okay? Now in this case, since the negative 32 is in parentheses, negative 32 to the 0, whoopsie, negative 32 to the 0 power, it's positive 1. So this is just like when we square something. Remember, if the negative is outside of the parentheses, if the negative is outside or not in parentheses, then it's going to take the opposite. If it's inside, then it's going to be positive. Okay? Now, the power of 0. So here's the thing. Any non-zero number raised to the power of 0 is 1. Now, we're going to talk about this a little bit more tomorrow, about why this is. I'm going to show you exactly why this is. But this is 1, that's 1. X to the 0 is 1 when x isn't 0. And I'm going to explain to you more tomorrow why you can't use 0. Okay? So think about these rules. Tomorrow in class, we're going to actually talk about them. We're going to go through them, and we'll fill out our foldable. All right? Have a good day.